Welcome to NCX Maths. So today in this video we are going to prove this theorem, which is finite intersection of open sets in R is open in R. So let's start the proof. So for this we are going to consider a collection of open sets. Let this collection of set be AI, where I runs from 1 to infinity. So this is the collection of open sets in R, that is A1, A2, A3 and so on. And now we're going to prove that their finite intersection, let's suppose the intersection of all these open sets I, and since this is the finite intersection, so here I runs from, let's say, 1 to n. So now this is the finite intersection of the open sets AI, where each AI is open in R. And suppose we are going to name it, let's say T, and we're going to prove that this set T is an open set. So for this, we consider X to be an element of T. Since we have to prove that T is an open set, so we are going to prove that this X is an interior point of T. So for this, since X belongs to T, and this T is the collection, the finite intersection of open sets in R, and this finite intersection also have the possibility that this intersection might be an empty set as well. So in case if T is equal to phi, because we may have their finite intersection empty set as well. So if this is the case, so it's obvious that we already had a proof on this that an empty set is an open set. So this proves that T is open, and in this case our theorem is proved. So if T is not an empty set, if T isn't an empty set, then let's say since X belongs to T, so X belongs to T, so which is the intersection of finite intersection of these open sets AI. So we must have, by the definition of this intersection, X must belongs to all these AI. For all I, we can write it X belongs to AI for all I. Since X belongs to their intersection, so X should belongs to all these AI. For all I means, so this I runs from 1 to 2 n. And also we know that each AI is an open set, since all AI is an open set, so we must have, by the definition of openness, there exists, let's say, Ri greater than 0, such that ball with center X and radius R, this should entirely lie in the set AI for all I. So since X belongs to AI and AI is an open set, so by definition open set, this X is an interior point. So by using the interior points property, there exists a radius Ri, so that the ball with the center X and radius Ri should entirely belong to the set AI for all I, which runs from 1 to n. So we can say that since this ball with center X and radius Ri belongs to AI for all I, which runs from 1 to up to n, so now we can conclude that there exists Ri greater than 0, such that the ball with center x and radius ri is subset of ai for all i and it's very clear that this ai is subset of t, so we can write that ball with center x and radius ri which belong to which is a subset of t, and this proves that this x is an interior point of this set t, and this shows that this random point, since x is an interior point of the t, so we can conclude that each and every point of t is an interior point of t, so we can say that t is an open set. And this concludes that the finite intersection of open sets in R is open in R. And that's all for today. So I hope you found this video useful, and if so, please like, share and subscribe the channel. Thanks for watching. Have a nice time. So I hope you found this video useful, and if so, please don't forget to like this video and subscribe my channel for more higher mathematics related videos. Thanks for watching. Have a nice time.